Yo, good day guys. I am Lhansen MD Guzman from BSED Math 2B, and today we're going to answer question number 33. Here we have given matrix A where the first row is 2, 1, and the second row is 0, 1, and the third row is negative 2 and 1. And matrix B where the first row is 2, 3, 1, and the last row is 0, 4, and negative 1. In this given, we will verify if A B transpose is equal to B transpose A transpose. A little bit info why it's written as B transpose A transpose, not A transpose B transpose. Because in chapter 2 remarks, it says, remember that you reverse the order of multiplication when forming the transpose of a product. The transpose of AB is AB transpose is equal to B transpose A transpose, and is not usually equal to A transpose B transpose. So the first thing we're gonna do is to solve A B transpose. By substituting the given, we will get this. So now, we can do the solve by multiplying each row in the first matrix by the column of the second matrix. So here we go. 2 times 2 plus 1 times 0 is equal to 4. 0 times 2 plus 1 times 0 is equal to 0. And negative 2 times 2 plus 1 times 0 is equal to negative 4. We will do the same process. 2 times 3 plus 1 times 4 is equal to 10. 0 times 3 plus 1 times 4 is equal to 4. And negative 2 times 3 plus 1 times 4 is equal to negative 2. And last, 2 times 1 plus 1 times negative 1 is equal to 1. 0 times 1 plus 1 times negative 1 is equal to negative 1. And negative 2 times 1 plus 1 times negative 1 is equal to negative 3. So after this, we can now say AB transpose is equal to 4, 10, 1 as the first row, and 0, 4, negative 1 as the second row, and negative 4, negative 2, negative 3 as the last row. So we see it's a transpose matrix. We will simply interchange its rows and columns to give us its transpose. In this matrix, it has 3 rows and 3 columns. The first row becomes the first column. The second row becomes the second column. And the last row becomes the last column. So AB transpose is equal to 4, 0, negative 4 as the row 1, 10, 4, negative 2 as the row 2, and 1, negative 1, and negative 3 as the row 3. Now we have the result of AB transpose. We will look for B transpose, A transpose for us to verify if AB transpose is equal to B transpose, A transpose. Let's solve for the B transpose, A transpose. Again, we will substitute the given. And we see it's a transpose matrix, so we will do the same process where we will interchange its rows and columns. The rows become the column, and the columns become the row. And then we can solve it now by multiplying each row in the first matrix by each column in the second matrix, as like what we did before. So 2 times 2 plus 0 times 1 is equal to 4. 3 times 2 plus 4 times 1 is equal to 10. And 1 times 2 plus negative 1 times 1 is equal to 1. We will repeat the same process. 2 times 0 plus 1 times 0 is equal to 0. 3 times 0 plus 4 times 1 is equal to 4. And 1 times 0 plus 1 times negative 1 is equal to negative 1. And last, 2 times negative 2 plus 0 times 1 is equal to negative 4. 3 times negative 2 plus 4 times 1 is equal to negative 2. And 1 times negative 2 plus 1 times negative 1 is equal to negative 3. And it results as 4, 0, negative 4 as row 1, 10, 4, negative 2 as row 2, and 1, negative 1, negative 3 as row 3. We can see B transpose, A transpose, and AB transpose are the same. We can now say they are equal.